All right, so we have another logistic growth model. Okay, we're talking about heart disease, so it's another one of those real-world problems. And it says the logistic growth function, p of x equals 90 divided by 1 plus 271 e to the power of negative 0.122x. And this equation models the percentage, p of x, okay, p of x is the percentage, of Americans who are X years old, so we know that X is the age, and have some coronary heart disease. Use this function to find at which age, okay, so we're going to find the age at which the percentage of Americans who have some coronary heart disease is 23%. All right, so the last problem we saw, they gave us the age, the x. And once we plugged that in, we just had a lot of calculator work to get the answer here to find the percentage. But this time, they are giving us the percentage. And once we plug this number in right here, we're going to have some algebra that we have to do to find this x. Okay, let's go ahead and do it. Okay, our p of x is 23. So we're going to find at what age do we have this 23%. So 23 goes right here for the p of x, and we're going to drop down the right-hand side. Okay, now we want to get this x all by itself. First thing to note is that it is down here in the denominator. Okay, so to get it out of the denominator, what we're going to have to do, we're going to multiply both sides times that denominator. So this side times the denominator, so that you will have no more x in the denominator, and then this side times the denominator, in which case your x is going to be out of the denominator. So let's go ahead, let's see how that works. Okay, so what I do to the left side I have to do to the right side, vice versa. So what's going to happen is this denominator and this denominator are going to reduce down to 1. So on the right hand side I have just the number 90. And I have all this stuff on the left hand side. I have 1 plus 271 e to the negative 0.122x times 23. Okay, so if you didn't know, if you wanted to, you could distribute the 23. But if we're trying to get this x by itself, we can easily get rid of that 23 by dividing out both sides. Left side divided by 23, right side divided by 23. And we'll see that the 23 over 23 reduces down to a 1. Okay, so here we are now. 1 plus 271 e to the negative 0.122x. And that equals 90 over 23. Now, you can leave that as a fraction. I'm going to go ahead and put it in the calculator. 90 divided by 23. And it gives me 3.913043478. Okay, I don't like losing any information, so I put all the decimals. All right, the reason that I put that and turned that into a decimal is because my next few steps, this side would get really complicated and I'd have to do it all in the calculator anyway. So continuing on to get my x by itself, the next thing I'm going to do is I'm going to get rid of this plus 1. Okay, how do we get rid of a plus 1? Well, we are going to subtract 1 from the left hand side of the equal sign and subtract 1 from the right hand side of the equal sign. 1 minus 1 is 0, so now I have 271 e to the negative 0.122x, and that's going to equal 2.913043378. All right, continuing on to get my x by itself. let's go ahead and get rid of this 271. This is 271 times e to that exponent. So to get rid of multiplication, we are going to divide. I will divide this whole side by 271, and I will divide this whole side by 271. On the left, 271 over 271 reduces down to 1. So I'm left with e to the power of negative 0.122x. And that is going to equal, let me get my calculator, and type in all these numbers, 2.913043478 divided by 271. And I get this beautiful number of 0.010749,238. Okay, now that's not a good looking number, but I'm not done yet. I'm not ready to analyze what that means. All right, next step. Still trying to get this x by itself. Now, this x is up in the exponent. I need to take this x and I need to bring it back down to earth. So what I'm going to do, because it's in the exponent with an e, I'm going to take the natural log of both sides. I'm going to take the natural log of the left side, and I'm going to take the natural log of the right side. All right, now I need some more space, so I'm going to use some internet magic here to move this stuff over to the left a little bit. Wow, isn't that nice? Okay, now let's take this. I'm going to put it over here, and now let's see what we have. Okay, this is one of those properties where the natural log of e to the power of anything is that anything. Okay, so the left-hand side is negative 0.122x, and it equals the natural log of 0.0107492. Okay, let me put that property for you right up here. Okay, and you can see that it was this one right here. Okay, that's why we took the natural log, is because I knew I could take that e from the exponent and bring it down to earth. All right, one more step to get my x by itself, and that is to divide. We're going to divide both sides by negative 0.122. All right, and then it is a calculator problem. This and this reduces, giving me x by itself. So x equals the natural log of that decimal divided by negative 0.122. So let me get my calculator. ln, natural log of 0.010749,2, close parentheses, okay, and I'm going to hit equals. All right, so I see that my natural log of all that stuff is negative 4.5329,23946, and I am going to divide that by a negative 0.122, and let's see what I get. Divided by negative 0.122, and I get 37.155, and on and on and on. Now, let's go back to the question. Okay, I found something here. What did I find? What is the age at which 23% of Americans have some coronary heart disease? All right, 37.155. Now, they're going to ask me to give the age rounded to the nearest number, to the nearest whole number, I guess. And that's going to be, is this closer to 37 or 38? Yeah, it's closer to 37. Okay, so my answer is going to be 37. All right, now, do I believe this? Do I think that 37, at the age of 37, 23% of Americans have some kind of coronary heart disease. Sure, that's not crazy to think. Almost a quarter of everybody by the time you're 37. That's a lot. I need to start exercising, but it's not outrageous to think. So that's going to be my answer.